Good morning, students. Welcome to chemistry class. Chapter 2 is matter around us pure. In the previous class, you have learned the difference between the pure substance and the mixtures. You know that most of the natural substances are not chemically pure. Different methods of separation are used to get individual components from a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like handpicking, sieving, filtration that we use in our day-to-day life. Sometimes special techniques have to be used for the separation of the components of a mixture. The special techniques that you are going to learn in this class are evaporation, centrifugation using separating funnel, sublimation, chromatography, simple distillation, fractional distillation, and crystallization. The first activity is separation of colored component, that is dye particles, from blue or black ink by evaporation. You know that ink is a mixture of dye in water. If it is blue ink, blue colored dye particles present in water. If it is red ink, red colored dye particles will be dissolved in water. The principle to separate volatile component from the non-volatile component of a mixture by the method of evaporation. Here, in the mixture of ink, the volatile component is water and the non-volatile component is the dye particle. What are the apparatus required for this activity? Beaker, watch glass, Bunsen burner, ink and water. Procedure: fill half beaker with water. Put a watch glass in the mouth of the beaker. Put few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see that evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. What do you observe? Water gets evaporated from the watch glass, leaving behind the dye particles of the ink. Now answer the following questions. What do you think has got evaporated from the watch glass? Yes, you are right. Water has got evaporated from the watch glass since it is a volatile solvent. The second question, is there a residue on the watch glass? Yes, there is a residue of dye particles on the watch glass. The third question, is ink a single substance, that is its pure substance, or is it a mixture? Yes, you are right. Ink is a mixture of dye in water. So we have separated volatile component, that is solvent, from its non-volatile solute by the method of evaporation. The second activity is separation of cream from milk or butter from cream by centrifugation process. Principle: the denser particles, that is the heavier particles, are forced to the bottom and lighter particles stay on top when spun rapidly in the centrifugation process. Procedure: take some full cream milk in a test tube. Centrifuge it by using a centrifuging machine for 2 minutes. If a centrifuging machine is not available, you can do this activity at home by using a milk churner used in the kitchen. If we have a milk dairy nearby, visit it and ask how they separate cream from milk and how they make cheese, that is paneer, from milk. What do you observe on churning the milk? Explain how the separation of cream from milk take place. The answer is the denser particles of milk are forced to the bottom and lighter particles of cream stay on top and spun rapidly in the centrifugation machine. Where we are using this or where we are applying this centrifugation process. This technique is used in diagnostic laboratories for blood and urine test. And it's also used in dairies, that is the milk dairies, and home to separate butter from cream. It's also used in washing machines to squeeze out water from wet clothes. Before getting to the activity, understand the difference between miscible liquids and immiscible liquids. What are miscible liquids? When we add few drops of milk in water, they do not separate out in layers. So they are miscible liquids. That is, water and milk are miscible liquids. Then what are immiscible liquids? When we add few drops of cooking oil or kerosene oil in water, they separate out in layers. So water and cooking oil or water and kerosene oil are immiscible liquids. Now let's see the activity. The separation of immiscible liquids using separating funnel. The principle: immiscible liquids separate out in layers depending on their densities. Procedure: let's try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Collect it in a beaker. Close the stopcock of the separating funnel as the oil reaches the stopcock. What do you observe? Based on the difference in density, the immiscible liquids are separated using separating funnel. Where do you find the application of this technique? This technique is used to separate mixture of oil and water. In the extraction of iron from its ore, the lighter slag, that is the impurities, is removed from the top by this method to leave the molten iron at the bottom in the furnace. Before getting to the next activity, let's recall the process of sublimation that you have studied in chapter 1. What is sublimation? Sublimation is the transition or conversion of substance directly from solid to the gaseous state without passing through the liquid state and vice versa. Some examples of sublimable substance are camphor, naphthalene, ammonium chloride and anthracene. The next activity is separating a mixture of salt, that is the impurity present in ammonium chloride. Here salt is a non-sublimable substance and ammonium chloride is a sublimable substance. That is, ammonium chloride on heating directly converted from solid state to vapor state without going to the liquid state. The principle: separating a sublimable volatile component from a non-sublimable impurity by sublimation process. Procedure: take a mixture of salt and ammonium chloride in a china dish. Invert a funnel above the china dish and plug the end of the funnel with cotton ball. Heat the mixture using the Bunsen burner. What do you observe? On heating, ammonium chloride changes directly from solid to gaseous state. The vapors of the ammonium chloride gets collected on the sides of the funnel. The non-sublimable impurity, that is salt, is left behind in the china dish. The next activity is separation of colors in black ink using chromatography. What is chromatography? Chroma in Greek means color. This technique was first used for separation of colors, so this name was given. The principle in this process is separation of different solutes that dissolve in the same solvent by chromatography technique. Procedure: take a thin strip of filter paper. Draw a line on it using a pencil approximately 3 cm above the lower edge. Put a small drop of ink at the center of the line. Let it dry. Lower the filter paper into the jar or glass containing water so that the drop of ink on the paper is just above the water level and leave it undisturbed. Watch carefully as the water rises upon the filter paper and record your observation. What do you observe on the filter paper as the water rises on it? Do you obtain different colors on the filter paper strip? The answer is the ink that we use as water as a solvent and dye is a solute soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. Usually, dye is a mixture of 2 or more colors. The colored component that is more soluble in water rises faster, and in this way the colors get separated. With the advancement in technology, newer techniques of chromatography have been developed. The applications of this technique we are using to separate colors in a dye, to separate pigments from natural colors, and to separate drugs from blood. The technique simple distillation is used for separating a mixture of two miscible liquids. Principle: separating a mixture of two miscible liquids with a difference in their boiling point is more than 25 K. Procedure: let's try to separate acetone and water from the mixture. Take the mixture in a distillation flask, fit it with a thermometer. Heat the mixture slowly, keeping a close watch at the thermometer. Acetone vaporizes, condenses in the condenser, and can be collected from the condenser outlet. Water is left behind in the distillation flask. Simple distillation is used for the separation of components of a mixture containing two miscible liquids. Here we have taken acetone and water that boils without decomposition and have sufficient difference in their boiling points. Do you know the boiling point of acetone? The boiling point of acetone is 56 degrees Celsius. Boiling point of water, you know very well, it's 100 degrees Celsius. Fractional distillation. Principle: separating mixture of two miscible liquids with difference in their boiling point is less than 25 Kelvin. Procedure: for the separation of different gases from air, different fractions from petroleum product, fractional distillation process is used. The apparatus is similar to that for simple distillation except that a fractionating column is fitted in between the distillation flask and the condenser. The simple fractionating column is a tube packed with glass beads. Do you know why they are packing with glass beads? The beads provide surface for the vapors to cool and condense repeatedly. Separation of components of air by fractional distillation. You know very well, air is a mixture of gases like nitrogen, oxygen, argon, and carbon dioxide. The principle: separating components of homogeneous mixture of air by fractional distillation. Procedure: the air is compressed by increasing the pressure and then cooled by decreasing the temperature to get liquid air. This liquid air is allowed to warm up slowly in a fractional distillation column where the gases get separated at different heights depending upon their boiling points. The air is allowed to pass through the filter to remove carbon, dust and other impurities. The air then passes through a chamber where it is compressed to high pressure. The hot air from this chamber is allowed to pass through a coolant, that is, the freezing cold water will be circulated inside the chamber. The temperature gets reduced and the cold compressed air from this chamber is allowed to pass through a separator where the solid carbon dioxide, that is nothing but dry ice, is removed here, and the air is allowed to pass through a expansion jet. When this cold compressed air is allowed to squeeze out through expansion jet, the liquid air is obtained, and this liquid air is allowed to warm up slowly in a fractionating column. The gases get separated, that is, nitrogen, argon and liquid oxygen get separated at different heights depending upon their boiling points. The boiling point of nitrogen is minus 196 degrees Celsius. The boiling point of argon is minus 186 degrees Celsius. The boiling point of oxygen is minus 183 degrees Celsius. So in this way, the components of air, that is nitrogen, argon and liquid oxygen, get separated by fractional distillation process. The next technique you are going to learn about crystallization. Crystallization is the process that separates a pure solid in the form of its crystals from a solution. Crystallization technique is better than simple evaporation technique. Some solids decompose or some like sugar may get charred on heating to dryness. So evaporation technique is not suitable for such solids. Some impurities may remain dissolved in solution even after filtration. On evaporation, these impurities contaminate the solid. So crystallization technique is better than simple evaporation technique. Purification of salt from an impure sample by crystallization. Principle: separation of pure solid in the form of crystals from the solution by crystallization. Procedure: take some impure sample of copper sulfate in a china dish, dissolve it in minimum amount of water, filter the impurities out. Evaporate water from the copper sulfate solution so as to get a saturated solution. Cover the solution with filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulfate in the china dish in the pure form. This process is called crystallization. What do we observe? The soluble impurities present in the copper sulfate solution get separated and we get pure copper sulfate crystals. Where do we find the application? This process we are using for the purification of salt that we get from seawater. Then separation of crystals of alum, that is pitcairn, from impure samples. Do you know the processes involved to get the supply of drinking water to your home from the waterworks? The processes involved in the purification of drinking water are sedimentation, filtration, and chlorination. So we have seen many separation techniques in this chapter. By choosing one of the above methods according to the nature of the components of a mixture, we get pure substance. With advancement in technology, many more methods of separation techniques have been devised. This lesson, we have learned different techniques used to separate the components of a mixture like evaporation, centrifugation, using separating funnel, sublimation, chromatography, simple distillation, fractional distillation, and crystallization. Thank you. I hope you all enjoyed this lesson.